Hello and welcome back. In this video we'll finish up section 2.8 on distance in circles. So just to remind us, the standard equation of a circle is written thusly, where we have x minus h squared, y minus k squared is equal to r squared. R is the radius and hk is the center. So we have the center at the coordinates hk, which is what we are subtracting from x and y respectively, and then the distance from the center to the outside to the circle itself is going to be r, and it's r in every direction. So let's take an equation and learn about the circle it represents. So let's find the center and radius of the circle whose equation is x plus 3 squared plus y minus 1 squared is equal to 4. Well, right away, we can, if we write this down, we can begin to identify some of the radius and the center. So in the equation for the standard equation for the circle, we want x minus something. Here we have x plus 3. So in order to turn this into minus, we're going to write this as x minus negative 3. So we can see that x plus 3 squared is the same thing as x minus negative 3 squared, because we're subtracting a negative, which is just a positive. In the next one, we just have y minus 1. We already have y minus a number, so that's great. And 4, I want to write this as something squared. Well, 4 is just 2 squared. So now that we have this formula, we can write down exactly what things are. The center is going to be at the coordinates negative 3, 1. It's x minus the x coordinate and y minus the y coordinate. So this is x minus negative 3 and y minus 1. The radius is hanging here at the end, and it is what is squared. So the radius is going to be 2. Okay, so this means that we can graph it. So let's do this. So the center is going to be at negative 3, 1. So 1, 2, 3. So we've got 3 back and 1 up. So here's the center. So if here's the center, we know that the circle is going to be everywhere that's 2 away from the center. So if we go 2 straight up, this is going to be a point on the circle. If we go 2 straight to the right, this is going to be a point on the circle. If we go 2 straight down, this is a point on the circle. And if we go 2 straight to the left, this is going to be a point on the circle. So in this case, I'll try to draw this a little bit more accurately so that it passes through these points. And we have our circle, roughly. So in essence, the important points are that we know where the center is. So the center is going to be at negative 3, 1. And we know that it has radius 2. So the circle is going to extend 2 up. Well, 2 above this point is going to be negative 3, 3. It's going to extend 2 to the left, and that will be negative 5, 1. If we extend 2 down, it's going to be at negative 3, 1. And if we extend 2 to the right, that's going to be at negative 1, 1. Okay, so we can identify the center, the radius. We've got our big graph. So we found the center and the radius, and we've graphed it. So now we need to find the domain and range. So one thing I want to point out here is that this is not, a circle is never given by a function. Why? It doesn't pass the vertical line test. If you draw a vertical line through it, it hits it in more than one spot. So this is not a function. So we can't say find the domain and range of the function, but any set of pairs of elements, of pairs of numbers, say negative 3, 3, negative 1, 1, negative 3, 1, and so on. All these form a relation. And even with a relation, we can talk about the domain and range. So what are the possible x values along here? The domain is just all the possible x values. Well, we can see that all of the x values stretch. This is the furthest left x value, and this is the furthest right x value. So the x's will range between negative 5 and negative 1. So the domain of our relation is going to be from negative 5 up to negative 1, and it includes negative 5 and negative 1. The range are going to be, the range is all the y values. So we can see that's the highest y value, and this is the smallest y value. That should be right at negative 1. So for the y values, y never gets bigger than 3, but it never gets smaller than negative 1. So the range, all of the possible y values are going to be from negative 1 up to 3, including negative 1, so a square bracket, and including 3, so another square bracket. So here are the domain and range of this relation, of this shape. Okay, so one thing that's a little bit interesting is if we take the standard equation of a circle and we FOIL everything out, it won't look like the standard equation of a circle anymore. So if I take x plus 3 and I square it, I'm going to get x squared plus 3x plus 3x, so that's 6x plus 9. If I take this this binomial and square it, we'll get y squared minus y is minus 2y minus 1, and that's equal to 4. And generally, when we have a polynomial, we normally like to make it equal to 0 on the right-hand side. So I'm going to subtract 4 from both sides. And if I combine like terms, I'm going to put my squared terms out front. I'm going to get an x squared and a y squared. Next, I'll do the x and the y. So here I've got 6x, and here I've got minus 2y. I've got 9, minus 1, minus 4. So 9 minus 1 is 8, minus 4 is equal to 4. So this equation doesn't look like the equation of the circle anymore, not in the standard sense. So this is one that is what we would call the general form of the equation of a circle. And the important points, we have an x squared and a y squared. We've got just an x term and a y term. And we've got just a number at the end, just this constant. And everything is equal to 0. So D, E, and F are just going to be these numbers right here. So in general, any equation that looks like this is going to give a circle. So let's take an equation that looks like this and transform it back into the standard equation of a circle. This process is maybe a little bit tedious, but there is just a method for doing this. So if I write down here what the equation of a circle should look like, well, it should be x minus plus or minus something squared plus y plus or minus something squared should be equal to something. So all I need to do is fill in these blanks down here in order to get this into standard form. So let's start by taking all of the x's and putting them out front, taking all the y's, putting them next, and we'll move the 23 to the other side. So I'm going to take both of our x terms and then put them out front, x squared plus 4x. I'm going to take our y terms. We've got minus, we have plus y squared minus 6y. And if I add 23 to both sides, I'm going to get this. I'm going to put these in parentheses just so that we're distinguishing these. So I've got all of my x terms out here. I've got all of my y terms out here. And you can see that I'm leaving a blank here. This blank we are going to fill in with numbers to make everything turn out nice. So when I take x minus something and I square it, I'm going to get x squared plus something times x plus something. So I just need to fill in this blank to make everything factor nicely. I also need to fill in this blank here to make everything factor nicely. And what we're going to do is we're going to complete the square. And this is something that we did a while back. And essentially what this means is that we are going to add b over 2 squared. And what is b in this instance? B is the number that's multiplying the linear term. So it's this coefficient here. So let's go through this example. So for this first term, so for the x term, we have a 4. So what I want to do is I want to take 4 divided by 2 and square it. 4 divided by 2 is 2, so that squared is 4. So what I want to do, and maybe I'll do this in red so that it's more visible, I'm going to add 4, but whatever I do to one side, I have to do to the other. Next, we've got this y term over here. So the number multiplying the y is negative 6. So I want to take negative 6 divided by 2 and square it. Well, negative 6 divided by 2 is negative 3. Negative 3 times negative 3 is 9. So I'm going to add 9. Maybe I can do this in blue. Okay. So the next order of business is to simplify things. So it turns out that x squared plus 4x plus 4, this simplifies into x plus 2 squared. And again, if we go backwards, if you take x plus 2 times x plus 2, we will get the x squared. 2 times 2 is 4, and 2x for the outside term and 2x for the inside term adds up to 4x. There's a reason why completing this square works. Here, what you'll notice is that this is going to be y minus 3 squared. Again, y squared minus 3 quantity squared is 9, and then y times negative 3 and negative 3 times y adds up to negative 6y. So everything here is simplifying, and then on this side we've got 23 plus 4 is 27, plus 9 is 36. So we now have the the standard form of the equation. So the steps involved were move the constant term to the other side and complete the squares. That's it. It's just those two steps. Completing the square is as simple as adding b over 2 squared, where b is this coefficient. So we added 4 over 2 squared and negative 6 over 2 squared. Whatever we do to one side, we do to the other. And to graph, again, here, the center of the circle, notice that this is going to be x minus a negative 2 squared. So the x coordinate is going to be at negative 2. The y coordinate of the center is going to be 3. And then what is the radius? Well, 36 happens to be 6 squared. So the radius is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So our circle is going to, if I can draw correctly, Looks something like that.